Evening. I'm Spot On Weather meteorologist Matthew Euler. Welcome to my latest video. In tonight's video, I'm going to discuss some of the teleconnections that we can expect for the upcoming winter. We're going to look at some of these teleconnections. We're going to look at to see whether they favor colder or warmer than normal temperatures. We'll talk about, whether they favor above or below normal precipitation. So we'll go ahead and take a look at this video tonight. I thought this was an interesting graphic on the opening slide. Now this is courtesy of the NOAAclimate.gov, and it's really an interesting picture here on the title slide showing this highway. Now the highway represents the jet stream, and you'll notice basically these teleconnections, which we're going to discuss some of them tonight, not all of them, for the upcoming winter, but these teleconnections really act to alter this long wave pattern, this upper atmospheric highway, the upper level winds in the jet stream, into areas of troughs and ridges, low and high pressure in the upper atmosphere. These teleconnections really do play into how this jet stream or this upper atmosphere highway is configured. So I thought this was really cool. I mean, in this diagram we have Rossby waves, which is that energy that kind of transfers from the troposphere to the stratosphere, and I really like the diagram. I think it's pretty cool. All right, so let's go ahead, and tonight in the overview of the video, I'm going to discuss the ENSO, the El Nino Southern Oscillation. We'll talk about the Indian Ocean Dipole, that teleconnection. It's abbreviated IOD. We'll look at the Quasi-biennial Oscillation, the QBO, and then we'll look at the Pacific Decadal Oscillation, the PDO. Now, I'm only going to look at these four particular teleconnections, and the reason I'm going to do this is because these teleconnections tend to be longer in duration, these teleconnections, as compared to, let's say, the Madden-Julian Oscillation or the North Atlantic Oscillation. Those are way more variable. So I wanted to just examine to see what our status is and the typical winter weather we'd have with these teleconnections and what we're looking for the upcoming winter. The first thing we'll talk about is ENSO, El Nino Southern Oscillation, and we're pretty much forecasting, NOAA has put it out, a weak La Nina this upcoming winter. And there's a 71% chance of an emerging La Nina between now and November. And it is projected to last through the winter months, December and January. It could potentially go over to ENSO neutral conditions in the late winter, potentially as early as February. If we look at the graphics here on this slide, the blue bars here in the bottom left-hand graphic, this represents La Nina. When you see the blue tall bars, that's La Nina. Over here on the y-axis is vertical axis on the left. This shows you the percent chance of various features here, various ENSO states. Again, blue, the tallest bar is La Nina. The gray bar in this graphic is ENSO neutral conditions. And the red bar here, vertical bar, is El Nino conditions. So you clearly see there's not much in the way of high probability for any kind of El Ninos. If you look at the percentages over here on the y-axis, on this vertical axis, they range from 0 to 100% for probabilities. The seasons are down here on the horizontal axis. So DJF represents the months of December, January, February. JFM represents the months of January, February, and March. And FMA is February, March, and April. So you notice how tall the blue bars are, right? And if you go right over here horizontally, you see the probabilities of certain conditions here for the upcoming winter season. We'll say December, January, February, the meteorological winter months. There's a 71% chance per the latest NOAA discussion for a weak La Nina. Now a weak one, not a moderate, not a strong, but a weak one. If we look over here on the right, we show the model predictions from IRI of the ENSO, and this is the latest outlook they issued for from September of 2024. And now that we're in October, we can say that was last month, right? We're showing you dynamical averages here in the pink line, or this magenta purplish line is a dynamical average of all the models, and then the green, the darker green line here represents statistical average of all the models. And so you can clearly see whether we're looking at dynamical average or statistical average of the models, the green and this magenta looking line. The dynamical models are a little bit stronger with the La Nina for the upcoming winter. And then the green line here, statistical average of the models is much weaker. So in general, you see all the different color lines here representing all the different types of model projections. And again, the solid green and solid magenta line here represents the average of those. So overall, we're looking at a weak La Nina for the upcoming winter. Let's just take a look now. Let's see what the Oceanic Nino Index, ONI, is looking like right here on the left. This is showing you sea surface departures in degrees Celsius. I want you to pay attention to this bottom left graphic here, though, right where my red dot is. This is currently showing the year 2024, where we're at presently. And, it has come down, the sea surface temperature anomalies. And it has come down, but it's still generally an ENSO neutral criteria. If you go above this red line, that indicates El Nino conditions. If you go below the blue line here, that would indicate La Nina conditions. So we're not quite below this blue dashed line, are we? And so technically we don't have an official La Nina just yet. If we look at the upper right-hand graphic here, shows the NSEP, OISST, sea surface temperature anomalies in degrees Celsius. This is the 28-day average of how the sea surface temperature anomalies have changed. So 28-day average, okay? And it goes from 5 August to 1 September 2024. I imagine this is going to be updated soon. And look at the orange colors and the white colors here, the brownish white colors. That indicates above normal sea surface temperature anomalies. Warming basically off the U.S. West Coast and warming over the North Central Pacific, stretching back west towards northern Japan. We also do see above normal sea surface temperatures across the western tropical Pacific waters. We see generally above normal water temperatures across the entire Indian Ocean here. Okay, we do see the signature of La Nina across the eastern, stretching a little bit further west of 120 degrees west longitude. We do see the blue shading here, which indicates the La Nina really trying to get going here, where the water temperatures are cooling or cooler than normal. Look at the Atlantic side here too. The main development region for the tropical area in the Atlantic remains above normal for water temperatures, and it's just massively above normal when you get north of 30 degrees north latitude across the northern and central North Atlantic. It's just insane how warm it is. And you also got well above normal water temperatures across the Arctic area there, north of Norway, Sweden, Finland area. Right now, let's look at the recent changes to sea surface temperatures. On the left here, we're showing you the blue coloring indicates below normal sea surface temperatures. The oranges and yellows and reds indicate above normal. So 28 August, we clearly see below normal sea surface temperatures off the west coast of South America in that tropical equatorial Pacific area. And then in 4 September, we kind of still see that blue coloring. 11 September, still we see some shades of blue now stretching out a little further to the west. And then 18 September, we see more of the below normal readings across the central, generally from 130 west to about 160 west, below normal sea surface temperature anomalies. Over here on the right, we show change in the weekly sea surface temperature anomalies, the global look. Look how warm things are. Look how warm these water temperatures are off of east of Japan across the northwestern Pacific into the north central Pacific. And we have well above normal water temperatures into the Bering Sea and extending north towards the Arctic Ocean. And then we do see some below normal sea surface temperature anomalies across generally from stretching from 120 west to about 155, 158 degree west longitude here on the equator. And then we see above normal temperature, sea surface temperatures off the southeastern U.S. coast, and also some additional above normal water temperatures south of Greenland, across the North Atlantic, south of Iceland, and off the west coast of Europe. Now, this is the forecast sea surface temperature anomalies for the meteorological winter months, December through February. Over here on the left, I'm showing the NMME forecast of sea surface temperature anomalies for the months of December, January, and February. And you see the blue color here. It sticks out like a sore thumb, doesn't it? That's going to be associated with your La Nina coming on, the weak La Nina. And so you see generally the blue coloring on the NMME forecast model stretching from about 110 degree west all the way westward to about 180 west. You see well above normal sea surface temperatures forecast for the winter, generally across the northwestern Pacific, extending eastward towards the north central and the central Pacific. You see slightly below normal readings off into the Gulf of Alaska and right along the U.S. West Coast. Slightly below normal water temperatures are forecast. And then you see well above normal water temperatures for much of the North Atlantic. Look over here in the middle now. We're showing the CFS V2 forecast for sea surface temperature anomalies for December, January, February. Very similar as far as location of the La Nina, the below normal, the blue colors here, below normal sea surface temperatures from the west coast of South America extending west, just to about around 180 degree west longitude, above normal temperatures again in the northwestern and the north central Pacific. And then we see below normal water temperatures on the CFS V2 off New England, extending up off of Nova Scotia and off of eastern Canada there. And over here on the far right, we have the GFDL SPEAR forecast for sea surface temperature anomalies. Notice that this stripe of blue coloring generally is further west, closer, generally extending from 120 west to 180 west. And so the CFS V2, I would say out of all three models for the sea surface temperature anomaly forecast for the La Nina and the blue coloring, the CFS V2 shoots more of a, the coloring here, below normal water temperatures extending into the eastern equatorial Pacific, whereas the other ones are kind of away from the coast of South America, the other two models, the one on the left here, NMME, and the one on the right here, GFDL SPEAR. One of the big questions I'm going to pose to you is, will this be an east-based or a central-based La Nina? And why do I even mention that? Well, previous research indicates that east-based La Ninas generally tend to favor more frequent negative Arctic oscillation, negative AO, and negative North Atlantic oscillation, negative NAO during the winter seasons. This is your typical La Nina impacts that you would get in a La Nina winter. All right, the trade winds will increase in strength. Those easterly trade winds, the tropical wind belts, they cause more warm water. Then to get pushed to the west, the winds push it further west, the warmer water. And as that top surface of water gets pushed further west, you're going to have colder water come up from the bottom or from the lower levels of the ocean upward in a process we call upwelling. And so you get warm surface water getting stronger trade winds pushing that warmer water, surface water west, and you get cooler water coming up from the depths, and that's called upwelling. So we have cooler surface waters as a result across the eastern and central equatorial Pacific. Additionally, one thing I want to mention here again, I'll show you some examples here in a minute. The weaker the La Nina, the less likely we will see the traditional La Nina weather across the United States. So again, this is what you'd expect in a typical La Nina winter. The source of this graphic is NOAA, climate.gov. And so you see blue indicating colder than normal temperatures during the winter season in December, January, February across Minnesota, the Dakotas, Montana. You get wetter than normal conditions along the Pacific Northwest from Washington State through Oregon and Northern California. You get drier than normal conditions across Southern California, Southern Nevada, right along the desert Southwest here, Arizona, New Mexico, into Texas, Louisiana, the Gulf Coast states, Mississippi, Alabama, Georgia, up into the Carolinas, and you generally get drier than normal winters with La Nina conditions. You also get warmer than normal winters here. You notice where the warmth stretches from eastern Oklahoma right through northern Arkansas, Tennessee, into North Carolina and Virginia. You have a warmer than normal winter with La Nina typically. And you get wetter than normal conditions here across the Ohio Valley, stretching back towards Illinois. So the bullseye of wetter than normal conditions in La Nina winters typically resides from Illinois, Indiana, Ohio, West Virginia, and Kentucky, right in this area. Now that's traditional, but the strength of La Nina matters here. And I already mentioned I showed you the NOAA forecast for the upcoming winter. It's showing a weak La Nina. So over here on the left, I show these are temperature anomalies, both sides here, both graphics, left and right. I'm showing you the differences in the temperature anomalies. Blue being colder than normal, the peach and the maroons and the reddish colors above normal air temperatures in the winter. Okay, so when we start with the weak La Ninas here on the left, 1954-55, 71-72, 2000, 2001, 1964-65, 83-84, and 1974-75. You look at this data, this information, right? Blue below normal temperatures, peach and maroon above normal temperatures for the winter. So you clearly see in 05-06, 11, 2011, 12, even 71-72 up to the Mid-Atlantic, and this 1974-75 up the eastern coast here. You clearly see it was milder than normal winters, right? But with a weak La Nina here, look at this. Look at this weak La Nina here. 54-55, generally cooler than normal on the East Coast. Again, 71-72 was warmer than normal. But 2000-2001, slightly cooler than normal along the East Coast. 64-65, near normal for Virginia, but slightly cooler than normal north of that, up to Maine. And then 83-84, the winter of 83-84, it was pretty cold across much of the country. So weak La Nina winters, there's a 50-50 chance for above versus below normal temps for the Gulf Coast states to the Mid-Atlantic. Over here on the right, we're showing strong La Nina winters. With this case, you notice more of the peach color here, and that indicates above normal temperatures for those winters. So for the eastern U.S., it's a pretty good bet with a strong La Nina in place. We're going to get those more traditional La Nina effects during the winter season, specifically from the Gulf Coast to Mid-Atlantic. We're going to get more of this, what I showed here. Bottom right-hand side, warmer and drier than normal for the Mid-Atlantic. Warmer and drier than normal along the southern U.S. The wettest and coldest areas are going to be, generally over the Ohio Valley, up through the northern plains, and the Pacific Northwest. So with a strong La Nina, it's a different story here on the right as compared to the left. Now, as far as precipitation anomalies, weak La Ninas are over here on the left, starting with 54-55, going all the way through 1974-75, 2000, 2001, and so on. Green on these maps, by the way, indicates above normal precip, brown below normal precip. Okay, so on the left here with a weak La Nina, there were some wetter than normal winters across the southeast and mid-Atlantic here in this data. Over here on the right, with strong La Nina winters, we did have a wetter than normal, strong La Nina there, 73-74 up the eastern seaboard. We did have drier than normal, 88-89 winter with a strong La Nina. Drier than normal, 1990-2001 up the eastern seaboard. 2007-2008, it was drier than normal in Virginia, over the Carolinas. It was wetter than normal just to the west of there, northwest of there. And then, look at this, 1949-1950 here, it was really above normal across the lower Mississippi Valley and Tennessee Valley, and drier than normal east of that from Florida up through the Carolinas, Georgia, Virginia. And over here on the right is 1998-99. It was slightly wetter than normal across the Mid-Atlantic, but not by much. All right, now that we've just talked about the La Nina, let's talk about the Indian Ocean Dipole, IOD. A neutral IOD is forecast through the spring of 2025. All right, so if we look at the left-hand graphic here, there's two boxes labeled here, right? There's one that's labeled west, there's one that's labeled east. And we assess the water temperature anomalies, sea surface temperature anomalies in these boxes. Now, if we have warmer than normal water in this area with the west box, if the water temperatures are warmer than normal where you see the west box, that indicates we have a positive Indian Ocean dipole. If the warmer waters are over here where the east box is labeled, that generally indicates a negative Indian Ocean dipole. We have warmer than normal waters now where this east box is located. So you have this change from warmer than normal waters in the western Indian Ocean. And then you have another winter, maybe you have the warmer than normal waters in the eastern Indian Ocean. And then you could have a case where it's just warm all the way across the ocean basin like it is now. So you really don't have any favorite areas of warmer than normal water temperatures in the western Indian Ocean or the eastern Indian Ocean. It's just warm throughout the whole Indian Ocean basin. What happens on the right here is you get a neutral phase of the IOD, the Indian Ocean Dipole in this case. And notice the vertical circulation, sinking air over the western Indian Ocean. The air then moves along the surface over towards the maritime continent area here, and then it rises over the western tropical Pacific, and then aloft that air goes back, works its way back to sinking air motion. This is one giant three-dimensional cell, right? This is the neutral phase of the IOD. All right, so why do we care about this? We have a neutral IOD that's forecast through spring of 2025. Here is the latest modeling data from the NMME forecast. This was issued in September, last month. And then you see the different color lines here. They represent different forecast models. But what I want you to really pay attention to is where all these color lines fall. They fall between this lower dash line and this upper dash line, right? This upper gray dash line. So everything is between these two grayish, blackish dash lines, which means we have a neutral forecast for the IOD. Look where all these lines are right here. They stay in the neutral territory for IOD. And what does that mean for us in the U.S. for winter weather? A neutral IOD will just generally have less impacts for us. Now let's move on to the Pacific Decadal Oscillation. This is known as the PDO. Now during a positive PDO, we have marine heat waves in the northeastern Pacific. They're more likely to be longer, stronger, and more frequent. A marine heat wave, by the way, is just abnormal warming of the waters, okay, when you see a marine heat wave. Now, this can cause heavy rain in these cases. When you have a positive PDO, you get heavy rain in the eastern Pacific Ocean. And you get drought during the negative or cold phases of the PDO in the same location in the eastern Pacific. During a negative PDO, the eastern Pacific Ocean becomes cooler and the western Pacific Ocean becomes warmer. There are shifts in the PDO between warm and cooler phases, or we can say positive and negative phases of the PDO, with each phase lasting approximately 20 to 30 years. So this is a fairly reliable, longer duration type of teleconnection, the PDO. Now let's look at this graphically now. This is courtesy of the University of Washington. We are looking at the positive phase of the Pacific Decadal Oscillation, the PDO on the left, the negative phase on the right. And by the way, when we talk about PDO, we're really focused on the water temperature, the sea surface temperature anomalies poleward of 20 degrees north latitude in the northern hemisphere. So we want to look at the, in ENSO conditions, we're looking at tropical waters near the equator. But with PDO, we're looking at the water temperature anomalies, colder or warmer than normal, north of 20 degrees north latitude. Right, so the positive phase over here on the left, when you see the oranges, the reds, the yellows, that indicates above normal water temperatures. Wherever you see the blue coloring, that indicates, blue and green actually, that indicates below normal temperatures. These are in degrees Celsius. So with the positive phase of the Pacific Decadal Oscillation, the PDO, we have above normal water temperatures north of 20 degrees latitude, generally along the west coast of the U.S. up to the Gulf of Alaska. Cooler normal waters, meanwhile, stretch across the north central Pacific, as well as back towards Japan. Over here on the right, we show an example of the negative phase of the PDO, where we have the opposite effect. We have well above normal water temperatures across the north central Pacific, stretching back to the northwest Pacific, all the way back to Japan. And then we have this green coloring, which indicates below normal water temperatures along the U.S. west coast up to the Gulf of Alaska. All right, I want to show you something now. So look at the negative phase graphic here on the right. See where all the above normal water is, the darker orange coloring? What did we say with this NMME forecast for sea surface temperature anomalies this winter? Look where the above normal readings are in all of these models, all three models. NMME, look at it, north central Pacific back to northwest Pacific. Look in the middle here again, CFS V2 forecast, same location, above normal water temperatures. And then over here on the right, the GFDL SPEAR forecast, the same. So we can say with a high degree of confidence based on this modeling that they're all showing the same look, that we are expecting a negative phase of the specific decadal oscillation for the upcoming winter. So that negative PDO is forecast for the upcoming winter, and you kind of see the graphic here on the bottom left. Look at the blue coloring here. Notice the water temperatures. When you see this blue spike below the zero line, that indicates below normal water temperatures. All right, so you clearly see that since 2020, we've been locked solid into a negative PDO. And here are some of the blue bars up here in the upper portion of this bottom left-hand graphic, showing you how far below normal some of these water temperatures are. All right, and then these are the models here in the bottom right. This one kind of shown here with the pink outline. This is the latest forecast model from August. I don't have the latest one from September just yet, but you see the projection here all the way through 2025 through April and May, forecasting for below normal water temperature, cooler than normal water temperatures in that area there of the eastern North Pacific. And, you know, there's an atmospheric connection, by the way, between La Nina, which we discussed is coming on for the upcoming winter, and the negative PDO. When you have both La Nina and the negative PDO, you actually have these conditions which are enhanced together. They work together. So if we look at now La Nina types, the PDO, we're going to combine these now. We're going to look at La Nina types, the PDO, and we're also going to look at the North Atlantic oscillation in winter, okay? Now, I have three cases here. I have the red line on this graph represents a Central Pacific-based La Nina. We have a negative PDO. Okay, so what happens when we have a La Nina that's Central Pacific-based? Let's say the cooler than normal water temperatures are out over the Central Pacific, west of 150 degrees west longitude, and you have a negative PDO, which we're expecting this winter. You're going to have pretty much a positive North Atlantic oscillation. Notice this zero line here down the middle. Well, your red line is well above the zero line into positive territory. That would indicate a positive NAO winter for the most part. Now, if you have an Eastern Pacific-based La Nina, as well as a negative PDO, that's this purple line. Look at the difference in the winter months, December through February. Look at how much of a difference this is between a Central Pacific-based La Nina and a negative PDO combined, and then an Eastern Pacific-based La Nina and a negative PDO. Just interesting stuff. Now this black dashed line, by the way, if you're curious, that represents an Eastern Pacific-based La Nina, where the coolest water temperatures are off the west coast of South America, plus a positive PDO. That's what this black dashed line indicates. We are not looking at a positive PDO this winter. We are looking at a negative PDO. So either the red line or this blue line will apply for the upcoming winter as far as whether we have a positive NAO with a Central Pacific-based La Nina or a negative NAO favored for the upcoming winter with the Eastern Pacific-based La Nina. All right, now let's examine one more teleconnection here. It's a quasi-biennial oscillation, the QBO. Now, a westerly QBO is likely this winter. How do we know this? Look at this graphic here in the bottom right. QBO is clearly in the westerly phase, which means that this blue line is to the right of this solid gray vertical line. Okay, so we're showing you this is millibars of pressure, 70 millibars up to 10 millibars. Okay, and we're showing this blue line well to the right of this millibar vertical line here. We're on positive values. See this to the right of the zero at the bottom? That blue line is in positive territory, which indicates a westerly QBO. And that projection is to continue through the winter. We had an easterly QBO last winter, but this winter is going to be westerly. Now the QBO is just a regular oscillation of winds, the stratospheric winds that exist above the equator. And whenever you have westerly winds, that's when you get the westerly QBO. It's associated with what you're seeing here on the right-hand side. And then easterly winds occur when you have easterly QBO, which we had last winter. And the easterly QBO is associated with these negative values here on the right. The positive values are associated with the westerly QBO. And look at the orange and blue colors here in the bottom left. Orange indicates westerly QBO, and blue indicates easterly QBO. But see how going back to 1981, it's a pretty regular patterns of westerly winds in the stratosphere, the westerly QBO, and then the blue color is a negative phase or the easterly QBO. Again, these are the stratospheric wind directions above the equator. Now, one other interesting thing here, when we talk about QBO, westerly QBOs per research are associated with milder winters in the eastern U.S., as well as a stronger Atlantic jet stream. And also, westerly QBOs make it less likely to see these sudden stratospheric warming events and a negative NAO in the winter season. And if that were the case, we would have a stronger stratospheric polar vortex and a lack of sudden stratospheric warming events. And we'd have more of a positive NAO, which would make a milder winter. This graphic here in the center bottom shows La Nina conditions, which we're expecting this winter, plus the westerly QBO, which we're expecting this winter. And this is from Barnston, Livesey, and Halpert from 1990 research they did. Wherever you see the plus symbol, that indicates above normal upper level heights, 700 millibars, 10,000 feet, associated with atmospheric ridges. You see another plus symbol here in the northeastern Pacific, associated with the atmospheric ridge, and then the negative symbols up over the Arctic area with the bluer colors here. So what does this tell me? That tells me with a westerly QBO along with La Nina, there's a good probability we're going to see some southeast ridge develop this winter, and it's going to be a milder than normal winter for the Gulf Coast and Mid-Atlantic. And all the coldest air is going to remain locked up over the Arctic area with a stronger polar vortex in the stratosphere. So here are my final thoughts for tonight's video. Boy, we covered a lot, didn't we? We examined specific teleconnections for the upcoming winter. Now, I want you to realize one thing. There's no two La Nina winters that are ever exactly identical. There's just no two La Nina winters. We cannot say this winter is going to be like the last La Nina winter. We just can't do it because small nuances in the atmosphere can change the whole outcome. The Mid-Atlantic, now I'm focused on Mid-Atlantic here, okay? The Mid-Atlantic teleconnection impacts. Everything we looked at in tonight's video, I want to cover this. So first of all, La Nina. We're expecting a weak La Nina. It favors a milder, drier winter for the Mid-Atlantic. However, again, the strength matters. So a weaker La Nina winter is not as likely to provide typical La Nina results. In other words, a weaker La Nina winter can be easily overpowered by another teleconnection. Now, the Indian Ocean Dipole, the IOD, we talked about it. It's forecast to be neutral, minimal impact to U.S. winter weather this year. The negative Pacific Decadal oscillation is locked in. That's going to favor a milder winter across the Mid-Atlantic and the eastern U.S. as a whole. The westerly QBO is expected, westerly stratospheric winds above the equator. That alone favors a milder winter, just looking at the westerly QBO phase. And then all these other teleconnections, now the AO, Arctic Oscillation, NAO, North Atlantic Oscillation, MJO, Madden-Julian Oscillation, I talked about that in my last video. MJO and La Nina winters. The PNA pattern, Pacific North American pattern, EPO, Eastern Pacific Oscillation, WPO, Western Pacific Oscillation. These are all teleconnections which cannot be accurately forecast beyond 2 weeks. You just simply can't. But they can all play a significant role in either dampening or enhancing La Nina's effects. All right, so, I didn't really talk about any of these more highly variable teleconnections, did I? I focused more on the longer lasting, more predictable teleconnections. Now, the effects on the weather and climate from La Nina can either be enhanced, it can be enhanced, period, sorry. The effects on the weather and climate from La Nina can be enhanced with a negative PDO. And then, this is the other bit of research, right? This is my last slide. So central base La Nina, what is that? According to the research conducted by Ding et al., this was the research paper. It's called Combined Impacts of the PDO and Two Types of La Nina on Climate Anomalies in Europe, and it was published in May of 2017. This particular research paper is what I really looked into here. All right, so the authors, Ding et al., they looked at central base La Ninas, so that means the coldest water temperature anomalies are west of 150 degrees west longitude. They then looked at the central base La Nina plus a negative PDO, which we're expecting this winter, right? That negative PDO. That's going to favor a positive phase of the North Atlantic Oscillation and a negative Pacific North American pattern. That means you're going to have a trough over the western U.S. and colder and wetter than normal across the western U.S. And you'll have higher pressure anomalies over the southeastern U.S. with that southeast ridge. And you'll get a stronger North Atlantic jet stream. Now that's if we have a central base La Nina, along with the negative PDO. We know the negative PDO is going to be there, but where are those colder than normal water temperatures going to basically center themselves? West of 150 degrees longitude or east of 150 degrees longitude? The eastern base La Ninas, which are those where the water temperature anomalies are greatest east of 150 degrees west longitude, plus a negative PDO. Look at the difference here. Complete difference. We're flipping the pattern to a negative NAO, North Atlantic Oscillation. That means we'd have anomalous anticyclone or high pressure, upper high over southern Greenland. So central based versus eastern based La Nina, where those coolest, the normal water temperatures set up in the La Nina matter. Can really affect the Rossby waves, can really affect the long wave pattern, the positioning of the jet stream, where the ridges and the troughs set up, where your storm track is set up. The other highly changeable teleconnections, such as MJO as an example, also need to be factored in. It can dampen the effects of La Nina. Early indications point to a mild, based on everything we looked at in the video, early indications point to a mild and drier than normal winter for the mid-Atlantic, as well as the southeastern U.S. and Gulf Coast. So there's a lot of variables here. I will say this. There's no guarantees when we're talking about the atmosphere. And we could talk about the La Nina all day long, right? This does not necessarily mean the whole entire winter is going to be drier or milder than normal, or wetter and cooler than normal in certain sections of the U.S. There's going to be periods where that's going to be disrupted by these other teleconnections, which are highly variable and play big into the overall atmospheric long wave pattern. All right. Now, when we go back here, one more look before I go tonight. The NMME forecast model, where are these sea surface temperature anomalies centered? Well, we mentioned it. Generally from about, looks like 190 to 100 degree west longitude back to about 180 west longitude, with the greatest, coolest temperature anomalies from 120 to 150. Okay, well, 150 is right down the middle of this cooler than normal sea surface temperature anomaly forecast. The same thing here. Although this does look a little bit more eastern based than the CFS V2 for the La Nina, for the cooler than normal waters. And then over here on the right, the GFDL Spear looks more central based La Nina, okay? So where do these cooler than normal waters associated with the weak La Nina this upcoming winter, where do they set up? West of 150 west longitude, east of 150 west longitude, right down the center. We take that 150 west longitude, go right down the center of this cooler than normal area of water temperatures. It all matters. It all matters. The strength matters of La Nina. We're expecting weak this winter. IOD not a factor. PDO negative. Look at the combining La Nina, PDO, and NAO. Just it's the same paper here. Okay, that graphic I showed you, it's from the same paper here. The effects of La Nina and the PDO. Combined impacts of PDO, two types of La Nina on climate anomalies. Look, there is so much to be excited about for the upcoming winter, but winter forecasting is never an easy task. And so that's all I got for now. I'm going to keep following this stuff, these teleconnections. My winter forecast will be out later in the month of October. And that's all I got for now, everybody. I hope you enjoyed the presentation and thought this was interesting. Until next time, everybody, take care and God bless everyone.